All right, that's that. Next is move semantics 1. What do we got? Cannot mutate immutable variable vec. Okay, so we already did something similar to that, and the help is actually telling us exactly what we need to do. But can you put a mute here? Yeah, you can do it there as well, because it's passing in a copy of the vector, right? This is a vector here, and it's not passing a reference to the vector. It's passing a copy of the vector, and so we can just declare it to be mutable there. But I think this is the answer they're looking for. It's not passing a copy of moving ownership to the. Okay, yes. You're right. I wasn't precise, and I need to be precise. You're absolutely right. It's not copying the vector and putting it in as the parameter. It's actually moving it. So it means that we cannot access vec0 after. If we tried to use vec0 after this, it won't work because it's been moved. There it says borrow a moved value vec0. So it's been moved to here. So because we own it, we can mutate it if we so desire. And I think the syntax here is probably better. Put the mute there and leave that alone. That's a more clean way of doing it. All right. Well, we'll leave it like that. And now we've got move semantics 2. Yeah, the whole point of this set of exercises is moving. So we should be talking about moving. Okay, so that was the answer they had there. All right, and now we don't have this. So the to-do says make both vectors vec0 and vec1 accessible at the same time to fix the compiler error in the test. So I wonder if they're looking for, like, I can just do a clone here. I don't know if that's the answer they're looking for. I mean, that gets us around the problem. Because now, instead of moving vec0, we make a clone of vec0 and move that into the function. And that way our original vec0 is still there. I believe that's what they're looking for. I mean, it works for me. All right, that's move semantics 2. Let's do move semantics 3. Oh, yeah, and this is what we were talking about before. You can see here now that it's talking about putting the mute keyword in front. Very good. All right, next, move semantics 4. Fix the compiler errors only by reordering the lines in the test. Don't add, change, or remove any line. Okay, so what are we doing here? We got a mutable variable x is being set to 100. We have y being set to a mutable reference to x. We have z being set to a mutable reference to x. And then we modify y, we modify z, and then we assert that x is 1200. Now the difference here, or the bug here, is that we have two mutable references at the same time. If I change the order of these guys, so we have y as a reference here, we can implicitly drop y when we create z here because we don't use y after this point. There was a term for that, not semantic lifetimes. There's a term for that where you can determine the lifetime of the y based on its last usage. Yes, thank you, Scoops. Non-lexical lifetimes. I think that was added in a version of Rust. Before, you'd have to do something like this and put them in separate scopes like this so that the y would be dropped. But now you can have them implicitly dropped. And if I save this file, that fixes the problem. If I try to use y here, right, it should fail because now it's spanning the two things. All right, so Move Semantics 4 is done. Let's take a look at Move Semantics 5. What are we doing here? Fix the compiler errors without changing anything except adding or removing references. Okay. Data to uppercase is expecting an ampersand string but found a string. Get char shouldn't take ownership. Okay. So we don't want to pass this as an owned string here. So it means we want to do that. And it means we want to pass a reference there. But now this should take ownership because we want to, it's expected a reference to a string and found a string. We don't want that. We want to just take ownership and do that. We still have a problem here because we don't want to pass in the reference. We want to pass in the string itself. And then we have that problem solved. All right, what's next? Structs 1. Okay, let's take a look at structs. To do, add the fields that the test regular structs expects. What types should the fields have? What are the minimum and maximum values for RGB colors? All right, so what are we looking for here? And this was another to do, add the fields that the test tuple structs expects. So it looks like in order to get this to compile, we need, I'm just looking here at the code, let's say 0 to 255. Let's call them U8s. So we have red, green, and blue for U8s. And this is expecting red, green, and blue as structs. So we can do that here. Red, green, and blue. Is that enough to get the code to run? Oh, and then I have to initialize. Okay, here we go. Let green equal. And this is a color regular struct of, we can do that and have it fill in struct variables. Red is looking for 0, green is looking for 255, and blue is looking for 0. Right, and then here we have a tuple struct of 0, 255, 0. Right? And then we have down here a unit struct. Instantiate a unit struct. Okay. Well, unit struct is just that. Unit structs are fun. They are indeed. I was just checking to make sure they didn't exist. Ooh. Oh, it is looking for unit struct. That's why I hit this. Oh, because of the S. I hit star to see if it was there. So I can just say unit struct here. There we go. That's better. Okay, so what's after structs 1? I'm guessing structs 2. There we go, structs 2. That's strings 2. Let's do structs 2. All right, so add no field name on type function tests your order. Oh, I see. So what are we doing here? To do, create your own order using the update syntax on the and the template above. Oh, okay, so it's created an order template. And it's filled in values here for the order. Bob for the name, 2019 for the year. Made by email is true. Item number 123 and count is 0. If I do this, let your order equals order template clone. Just to get the code to compile. Oh. Clone doesn't exist. Can I call copy as a copy? I'm just trying to make it, no. I can say order template, maybe it auto copy. Oops. No, that moves the value. Okay. I was trying to be clever. I guess I'm not clever. I wanted to get the assert to fail and fix the assert, but we can do it this way. Order. So what's the difference here? Name's different. We want the name to be hacker in Rust. I'll use the same syntax they have here, just to be consistent. The year is the same, made by phone, made by mobile, made by email, item number, and the count is 1. So count 1. And the rest comes from order template. Right? I think that's all they're trying to do, because it says using update syntax. And hopefully that passes. Hey, that passes. All right, next up is Structs 3. There. Structs contain data, but can also have logic. In this exercise, we've defined the package struct, and we want to test some logic attached to it. All right, so we have compilation errors. Is international. Add the correct return type for the function signature, and then this says read the test to use the method and find out when a package is considered international. Well, this is a Boolean because it's an is function. And this one is get fees is probably also U32. I'm going to have this return false for now. I'm going to have this return 0 because again, I like to get the code to compile first and then look at the tests. So we got 2 tests passing and 2 tests failing. So now we're going to look at the failing tests and see if we can fix those. The first one is create international package. So this is just asserting that the package is international. And so I'm guessing it's when the sender country is different to the recipient country. So we can just make that a test here, right? Self sender not equals self recipient. And that should hopefully pass that test. Yep, so now we have 3 successes and 1 failure. And the failure is in calculate transport fees. So we have cents per gram. And what we're doing is we're checking to see if, oh, I see. So cents per gram and just multiply it by the number of grams. Okay. So it's self weight in grams times cents per gram. This is the number of cents. Ah, there we go. All right, Structs 3 is done. Let's take a look at enums 1.